gonna be a one-timer. We'll put it in that slot.
Okay guys, so part 2, I guess, of this lesson, we're just going to continue on with reflections. This second half is pretty much all a review of what we did last week, so we'll see how much you remember.
Yeah.
Always making an appearance. Okay, so let's just recap. What are the 3 reflections we've learned so far? Bernie, tell the class. Not Bernie, sorry. Bruce. I wanted you to talk to the camera. Okay, forget that. Okay.
X-axis.
So we've learned how to reflect in the x-axis, the y-axis, as well as the mirror line y equals x. Just to review here, if we're reflecting in the x-axis, is that going to impact the y-coordinates or the x-coordinates? The y. They're changing sign, it's reflecting over the x-axis. Okay, so if we reflect over the x-axis, the function will affect the y-coordinate, so it's going to be y equals negative f of x. And if you wanted to rewrite that, you could put negative y equals f of x. Just moving the negative from one side to the other. So notice that if we take a look at the original graph, the thin line, if we have positive y-coordinates, so anything above the x-axis, when we reflect them, they reflect over the x-axis, and now they are negative. So the y-coordinates change. Another way to write this is in replacement notation. The y values become negative y values. So if they were positive to start, they become negative. Okay. Also, if we take a look on the original graph here, any y-coordinates that were negative after being reflected over the x-axis are now positive up here. Okay, so the notation, if we're going from y equals f of x to a reflection over the x-axis, it becomes y equals negative f of x. It's important to note, over the x-axis, the y values change. Okay, when we're reflecting over the y-axis, which values will change? Okay, so if x is positive after we reflect it, it's now negative. So you could just write replacement notation. X values become negative x values. Or they change sign. So if we're reflecting over the y-axis, and we start with the original function y equals f of x. If x is replaced with negative x, then we get the notation y equals f of negative x. So if you see these notations, you should know right away, reflection in the x-axis, reflection in the y-axis. Okay, lastly, we have a reflection in the line y equals x, and what's another term we could say for that? Inverse, good. So when we're reflecting in this mirror line here, y equals x, basically the x coordinates and the y coordinates exchange. So x goes to y goes to x. So if we reflect our original function in the line y equals x, then we either get the equation, the inverse function, or we can say that x is equal to f of y. So that's just a bit of a recap. We have already talked about the replacement notation, so we'll just move on to the next page. Now, I just kind of want to see where you guys are at. If you saw these 3 graphs, would you be able to reflect over the x-axis, the y-axis, or the line y equals x? Or should we practice? Maybe practice. You guys seem a bit quiet. Okay. Alright, so starting with y equals negative f of x. You can cheat if you need, looking back at the previous page. What value is going to change? Is it going to be the y coordinate or the x coordinate? Y. Good. So as a mapping or replacement notation, y is going to negative y, which means we reflect over the x-axis. So So if we're reflecting over the x-axis, and we've already stated that the y goes to negative y, Bruce, maybe help me out. If I started with negative 4, 6, what would my new point be?
4, 6.
Nope. We're reflecting over the x-axis,
Oh, true.
so the y coordinate's going to change. So it's still going to be negative 4, but instead of positive 6, it's now negative 6. Okay, so we'll work that out. Negative 4, negative 6. Have I gone too far? Sorry. Yeah, there we go. Okay, negative 2, positive 6 becomes negative 2, negative 6. We have negative, let's just go back to this point, negative 5, 0. The y coordinate's 0. Is it going to change?
No.
No. Not today's. Okay, we have the point 0, 4. What's it now?
0,
You guys are awesome. 1, 2, 3, 4. There we go. Okay, how about over here? It looks like we have positive 4, 0. The y value is 0, so it's going to stay at 0. Okay, here we have positive 7, negative 3, so it's going to be positive 7, positive 3. Okay, and then we have 9, 0, 0, cannot change signs, it's going to stay at 0. So once we've mapped out a few points, we can just connect the dots, and there's our reflection.
Dress.
Okay, reflecting over the x-axis. So just to review, we introduced a term that starts with an I. It describes points that stay in the exact same place.
Invariant point.
Awesome. They're called invariant points. We have 3 invariant points on this graph. So points that existed on the original function and the new graph. Okay. Where specifically are these invariant points located? On the x-axis, which is our reflection line. Okay, so if it's reflecting over the line, the invariant points will exist on that reflection line. Okay, now we have the notation y is equal to f of negative x. So what's the replacement? X is becoming, we look at y equals f of x, what's x now? Negative x. So if x is changing sign, we are reflecting over the y-axis. Okay, so let's just draw a little reflection line. And then this time when we look at our ordered pairs, the x values are going to change sign. So Bruce, you'll probably get this one now. Negative 4, 6 becomes?
4, 6.
Awesome. Okay, so this, if we take a look, it's 4 spaces from that y-axis. So it's going to be 4 spaces again, just on the other side. Okay, same thing, we have negative 2, 6, so x value changes to positive 2, 6. Okay, 0, 4. 0 is just going to stay, so that stays the same. Okay, let's do negative 5, 0 is going to become 5, 0. Over here we have 4, 0, so that will become negative 4, 0. Positive 7, negative 3 becomes negative 7, negative 3. And lastly, we have 9, 0, that will become negative 9, 0. Connect the dots. Where do our invariant points exist? Good, on the y-axis. Okay, there's only one this time. Bless you. Any questions so far? Okay, on the last one, again our original function is y equals f of x. This time we're reflecting over what? If x equals f of y. Good, so we'll draw our mirror line. reflection over y equals x. Where will the invariant point exist? It's the intersection of the original graph and the mirror line. Draw that a bit thicker. Okay, so if you want, you can just look at the x and y coordinates and switch them, or you can write a list of them and then switch them. So if we take a look at the original points, -5, 0, starting here, that will become 0, -5. We can plot that. Okay, -4, 6, that will become +6, -4. -2, +6 will become 6, -2. 0, 4 will become 4, 0. And 4, 0 will become 0, 4. So those are 2 points that exist on both the original and new, but they didn't remain in the same place. Only the invariant point stayed in the exact same place. 2, 2 stays at 2, 2. Alright, then down below we have 7, -3, that becomes -3, 7. And last point, 9, 0 will become 0, 9. So some of you may not need to do the point mapping on the side here, you might just switch them and then plot it right away. But it doesn't hurt, just to make sure that you get it 100%. After we've plotted all of our points, draw a nice line through all of them. And we should have the same shape, it's just reflected over the line y equals x. Okay. Alright, so if you look at the bottom of your page, there's the thin line, thick line. The thin line is showing the original graph, and the thick line is showing the transformed graph. Okay, we're dealing all with reflections, so you can guess that it will be one of the following reflections, either reflected in the x-axis, the y-axis, or the line y equals x. So a big hint for determining where it's being reflected is to mark out where your invariant points are. So in this case, is that on the x-axis or y-axis? No. But if I were to draw the mirror line, y equals x, does it cross through that one? Yeah. And if we take a look as well, we could mark out some ordered pairs, switch the x and y, and see that this is a reflection over the mirror line y equals x. Okay, on what line do we have an invariant point in this case? Good, the y-axis. So that's a reflection over the y-axis. And sorry, just going back to the function notation. If we started with y equals f of x and we're reflecting over y equals x, what's your equation? There's 2 different ways to write it. You can have x equals f of y, or you could write y equals the inverse of f of x. For the second graph, we're reflecting over the y-axis, which means the x-coordinates will change. So the new function will be y equals f of negative x. Lastly, invariant points exist on the x-axis, so that's our reflection line. And if we're going from y equals f of x to our new function after the reflection, it will be y equals negative f of x. The y coordinates change.